Hi everyone, I'm Alsamina and I'll be starting off our presentation today. Our problem statement is improving water management and disaster response through enhanced satellite imagery and segmentation techniques. And here's a quick overview of our presentation. We'll be walking you through our problem, the solution, our methodology, key implementations, and the results. Today, over 2 billion people live under high water stress, and by 2050, 1.6 billion will be at risk from floods. So these disasters are worsening due to climate change. This challenge directly connects to Sustainable Development Goal 6, clean water and sanitation. So it's not just about access to water, but also about monitoring, planning, and protecting water resources for the future. So as we look into deeper, the real issue isn't water scarcity, it's the lack of visibility, and that's exactly what our project aims to solve. And following this, Tanushree will take you through our problem and its solution overview.
Hello, this is Tanushree. I will be explaining about a growing global crisis that often remains unseen until it's too late. Water stress under the impact of climate change. Climate change is disturbing our water system. In fact, over 90% of natural disasters today are water related, causing major damages to lives, economies, and ecosystems. Between 2001 and 2018, 74% of disasters were tied to weather and water. By 2040, 1 in 4 children will live under extreme water stress. Vulnerable groups suffer the most, especially rural farmers, indigenous communities, the urban poor, and coastal populations are hit the hardest with vanishing water sources, flood risk. In this slide, we can see the image how climate change is reshaping our water systems in every direction. Floods, droughts, and rising temperatures are disturbing agriculture, hydropower, and drinking water supplies. Snowpack has dropped by 25%, river flows are declining, groundwater is being depleted faster than ever. All of this reduces water quality, destroys habitats, and threatens food security. From the graph, we can see that how average temperatures are shifting, leading to more extreme heat and fewer cold days. Just a small rise in average temperature causes a huge spike in hot weather events. And on the map, you can see that without climate change, water supply stays relatively stable. But with it, much of US, especially the southwest, faces up to 50% decrease in water availability.
Hello everyone, I am Hariharan and I will be explaining our solution overview. Our solution is an AI-based water monitoring system that uses satellite image segmentation to detect and track water bodies in near real time. Using a UNet deep learning model, we can accurately map flooded areas, monitor shrinking rivers and lakes, and support early warning systems. This helps in disaster response, urban planning, and climate policy, turning satellite data into powerful life-saving insights. It is a scalable, smart tool that brings real-time water intelligence to the forefront of climate resilience and water management. Now, I did like to invite Kavya to explain our methodology in the next slide.
Hello, this is Kavya and I'll be explaining the methodology of the image segmentation process. First, we acquired dataset from Kaggle which contained an image of water bodies as well as their binary mask, and we did pre-processing steps like resizing, normalizing and formatting the binary masks, and we split the dataset into training and validation part and used the training dataset to train the unit model for semantic segmentation.
Great greetings. This is Emerald Rechin here going to speak about implementation and application of our system. This system has wide real-world impact in disaster management. It helps guide flood responses. For irrigation, it supports drought mitigation by mapping water-rich areas. Insurers can access damage more accurately, while Smart City use it to plan resilient infrastructure. Environmental agencies benefit from monitoring encroachments and water quality. What sets it apart is its scalability. It's not just a research tool, but a practical solution for real-world time decision making. Our UNet model delivers strong results, 88% accuracy with a dice coefficient of 82.22% and IOU of 69.8%, proving its reliability in detecting water bodies. Classification metrics like 79.97% of precision and 84.59% sensitivity show it strikes a good balance between detection and accuracy. Why does this matter? Because such precision enables real-time flood detection, drought monitoring, and smarter water management. It's a scalable, ready-to-use tools for governments, planners, and environmental agencies. Thank you so much.